Hello students, welcome to EPG Pathshala. I am Dr. Rajiv Jain from Jivaji University, Gwalior. Today we are going to discuss about a module, food, feed and energy from solid waste under the paper Environmental Biotechnology. The learning objectives in this module are the different type basic concepts of energy, energy from waste, how to generate energy from waste, environmental aspects of generating energy from waste, and energy from solid waste. Energy, some basic, what is the energy? What is energy? Energy is an integral part of our daily life. We use electric current for many purposes, such as operating several appliances, heating, running machinery, and for creating radio waves that carry information over thousands of kilometers, lightning, etc. The heat generated by burning coal or oil or by fissioning a uranium nucleus is used to generate this electricity. The same heat is also used to power automobiles, aeroplanes, and ships. Electricity is also generated by releasing water from a height for running a turbine. In short, different forms of energy such as heat, light, electric, and mechanical are interconvertible, and that energy cannot be created out of nothing. Energy changes from one form to another, but energy cannot be created out of nothing. All life processes are also based on energy. The energy from food sustains biological functions of organisms. Muscle energy of humans and animals is obtained from food for doing work through its conversion as heat energy by releasing the chemical energy stored in the mechanical bonds of food materials through oxidation. So from where energy is coming from, you can say that muscle energy or any form of energy, it comes from different sources. It can change its nature. It may be converted from one form to another, but energy can neither be destroyed nor can be generated from nothing. The primary source of all forms of energy that sustains life on the planet is the solar energy, which converts carbon dioxide and water into carbohydrates and other organic compounds, in which energy is stored in the form of chemical energy. In certain situations, these compounds are transformed into coal, oil, and natural gas through geological processes, and when burnt, give heat energy by releasing chemical energy. The amount of solar energy that falls on the planet's surface each year is equal to the energy supplied by 227 million tons of coal, representing about 1 millionth of its total output. The rest streams out in all directions into space. In 1 second, the sun gives off more energy than the energy all peoples have produced till now. The sun will continue to supply energy at this rate for a few billion years to come. Energy from waste. Municipal wastes are the largest source of energy and will be the main fuel for any large-scale plant. Municipal wastes are composed of several fractions, of which domestic refuse only comprises between 50% to 70%. Other categories are the waste from waste reception centers, waste from districts' own functions such as housing, markets, and special collection of bulky waste and some trade waste. These latter categories are almost all bulky in nature but have a higher calorific value than domestic refuse. The CV of domestic refuse is about 9 mg per kilogram gross or 7.5 mg per kilogram net, whereas the gross CV of bulky waste has been measured in the range of 11 to 13 mg per kilogram. A reasonable assessment of the overall CV of the totality of municipal waste would be about 11 mg per kilogram gross. These figures underline the advantage of energy recovery purposes of burning the total combustible waste arising, and since bulky waste is costly to transport and landfill, it also makes sense from a waste disposal viewpoint. Other wastes such as general industrial waste, very similar to bulky municipal waste, tires, fragmentizer, waste from car shedding, wood waste, hospital waste, straw and chicken litter can also be utilized where they are of large enough quantities as economic outlet for the energy. However, there is a sound argument for building a large, efficient central plant designed to burn the maximum amount of waste arising in its catchment area. This will not apply to straw or chicken litter, which do not have sufficient fuel value in relation to their bulk to travel any distance economically, but it could apply to hospital waste if the appropriate handling arrangements were made. The economics of energy from waste revolve around the price obtainable for electricity. If heat can be sold in bulk as well as that will be an advantage, but really substantial opportunities for CHP are rare and electricity generation must remain the core activity. Economies of scale also favor the large central plant burning as big a range of wastes. The limit is probably set by the economics of waste collection and by the ability of the locality of the plant to cope with the traffic entailed. A capacity of about 1,200 tons a day is about the optimum without using satellite transfer stations to bring in waste from a field. Such a plant with an efficient boiler using waste with a net CV of 9.5 megajoule per kilogram ought to extract 0.75 megawatt from a ton of waste, postulating a generating capacity of 37.5 megawatt for 24 hours operating or 53 megawatt if only operated for 17 hours a day. The need in the future for the plant to be competitive emphasizes that every last kilowatt must be squeezed out of the waste. Environmental aspects of energy production. Using energy from waste to generate electricity is a green activity for two reasons. Firstly, as the Watt Committee has pointed out, a great majority of the waste is part of the natural carbon cycle and its carbon content will return to the atmosphere as carbon dioxide, whether by being broken down by bacteria or by being burnt. Therefore, waste used to displace any fossil fuel which would add extra carbon dioxide to the atmosphere will help to limit the greenhouse effect. Further to that, the bacteria convert much of the carbon to methane. Secondly, as a fuel has had no energy spent on it as opposed to coal, oil or even gas, which will have had a considerable amount of energy spent on them by the time they enter a boiler, such energy will have already made its contribution to the pollution of the atmosphere. While processing provides an opportunity to increase the amount of both ferrous and non-ferrous metals recovered, and as regards paper and plastic, if indeed the recycling of the latter is economic, these materials are probably only kept out of the waste stream for a couple of cycles before they enter it for good. The maximum amount of recycling that was likely to take place would have little effect on the recovery of energy from waste. Another aspect of the energy from waste is that outdated technologies are mainly responsible for generating large quantities of waste. These wastes may be liquid or gaseous. The industry-wise quantities of generation of all such wastes and their characteristics are not accurately known in many cases. Their unsystematic and hazardous way of management lead to serious environmental degradation. To meet the problem, the Government of India has set up the National Waste Management Council, which identifies the waste, suggests the technological alternative for reduction, recycling, reuse, and research and development. It also determines categories of areas specific measures will be needed and formulate action points as a basis for executive orders to be issued by government, including legislation, taxes, and incentives. The only way to tackle industrial waste is to regard it in terms of a management issue rather than in terms of a problem or an irritant, as is the case today. This would give the approach to this issue a more realistic and practical sense. Thus, it calls for a review of the entire manufacturing process, the purpose of which would be to identify possibilities of minimization of discharges, be it solid, liquid, or recover it at various production stages itself. Reusable, reprocessable, or sellable material which otherwise have at the end of the pipe being discarded as waste could be viably recovered. For this, a cost-benefit analysis taking into account additional process equipment needs to be made. Today, with the evolution of eco-friendly technologies, the company can very easily quantify what it stands to gain by a more efficient process. For this, it is necessary to take a look at the best available technology both in terms of efficiency and environmental compatibility. The very important thing is to realize the fact that it is damaging for any industrial enterprise in the long term to be anything other than environmentally friendly. To have such a management oriented approach in respect of waste, it is imperative that government and policymakers adopt an attitude which is conducive for industry to convert to more environmental friendly processes. The change should not only be in legislation but in utilization, in implementation of procedures, and in the functioning of the executive arms of the policy making bodies. The advantages of recovery are highlighted by the work being carried out at National Environmental Engineering Research Institute, Nagpur, as quoted in the report of the subgroup on industrial waste management under National Management Council in the Ministry of Environment and Forests. How overall here I want to say that if industry is generating waste, and naturally every industry will generate waste, so waste should be recycled in such a way that it is converted into products which are useful. And one of the essential requirement of industry is energy. So waste should be converted in such a thing that byproducts can be used, and conversion in byproduct should release energy which may be used again for running of the industry. Energy from solid waste. Energy can neither be created nor destroyed. It may be changed from one form to another, but the total amount of energy in the universe never changes and remains constant, which is the first law of thermodynamics. Actually, there is no energy scarcity, but there is energy resource scarcity. Energy is not depleting, but the energy resources are depleting. For example, the energy resources like oil, coal, gas, firewood are fast depleting. That is why energy resources scarcity is reported all over the world, as in many parts of India, including rural and urban areas. To overcome the growing shortages of oil, gas, electric power, and fuel wood, possibilities of recovering energy from all types of waste are under serious consideration. That is why our National Waste Management Council has set up a subgroup to study and identify wastes and to suggest action points for recycling and reusing these wastes and recovering energy from the waste. The subgroup has identified that in India, 322 million tons of agricultural residues, 1,365 million tons of animal dung, 49 million tons of agro-industrial byproducts, 5 million tons of night soil, and 10 million tons of urban residues are available. From the above mentioned statistics, it is evident that India very huge quantities of waste are generated. Definition of solid waste: any of a wide variety of solid materials as well as some liquids in containers which are discarded, unwanted or rejected as being spent, useless, worthless or in excess are called solid waste. The solid wastes are also the wastes arising from human, animal, birds activities. In fact, solid wastes include all solids or semi-solid materials that the processor no longer considers of significant value to retain. The term refuse is also used interchangeably with the term solid waste. Solid waste have the following characteristics: density, physical and chemical composition, that is equality, and quantity. The density, weight, physical and chemical composition of the solid waste affect the amount of energy recovery. The geographic location, season of the year and length of time in storage can affect the characteristics of solid waste. The variations in the characteristics in turn affect the energy recovery. Moreover, the information about the density, weight, physical and chemical composition are absolutely necessary for assessing the feasibility of resource and energy recovery, for evaluating alternative equipment needs, systems, solid waste management programs and plants. Therefore, the methods of measuring such characteristics are explained here. National Environmental Engineering Research Institute has prescribed a standard method to measure the density of solid waste. According to this method, the solid waste samples should be collected from the refuse mass. Then the samples have to be weighed and emptied into a box of 1 cubic meter capacity. The procedure should be continued till the box is full. The box should be filled and weighed thrice to get an average value of density of solid waste. This method was followed in some Indian studies. The solid wastes are heterogeneous in nature, so determining its physical composition is a difficult task. Common sense and random sampling techniques are required to determine the physical composition. Assessing chemical composition of the solid waste helps to extract energy from the solid waste. The following four important properties should be assessed to determine the chemical composition: proximate analysis, fusing point of ash, ultimate analysis, and heating value. Though the solid waste quantities can be measured by using volume or weight, it is better to express the solid waste quantities in terms of weight rather than volume, because the use of volume as a measure of quantity can be misleading. Most of the solid waste generation reported in literature are actually collection rates, not generation rate. The amount of solid waste generated is different from the amount of solid waste collected. To estimate the amount of solid waste generated in an area, the following methods are used. The methods are not being described in detail, but methods are weight volume analysis, load count analysis, materials balance analysis, These are the three methods. Next is the method of measuring energy content in solid waste. By taking samples of solid waste and doing chemical composition analysis, the energy content, that is the heat values of the solid waste, can be determined. If heat values of solid waste are not available, then it can be determined by indirect method. If heat values are not available, or if facilities are not available to do chemical composition analysis, then the already obtained heat value result by doing experiments by other researchers in India can be taken. For instance, in Chennai, 30 samples of solid waste from 30 different area units have been taken and energy content values have been found out. The energy content ranges from 3103 kilojoule per kilogram to 6651 kilojoule per kilogram, and the city average is 4595 kilojoule per kilogram. The results show that from 1 kilogram of solid waste, 4595 kilojoules of energy can be recovered as shown in table 2, which may be due to variations in the physical chemical compositions of the solid waste. Population, which may be due to the variations in the physical chemical composition solid waste. Second, population densities, packaging materials, lifestyles of the people USA, Japan and India, and this has been shown in figure 2, a comparative study. Moreover, in Chennai, before municipal staff come for refuse collection, some refuse collectors pick up combustible materials from the street dustbin and sell them for money. This may also be reason for less heat values from solid waste found in Chennai. Another very important thing is the energy conversion technologies. Three major types of technologies are available to extract energy from solid waste as shown in figure 3. Any one of the methods can be chosen depending upon the resources to be recovered and types of energy to be extracted. A brief discussion on each process of extracting energy will be discussed in the lecture. So one of the process is combustion process. Combustion process is direct burning of the solid waste. By burning the waste, steam is generated which is used to produce power with the help of turbine process. The energy efficiency up to 30% is recorded even under controlled conditions. So one of the processes by which energy is obtained from waste is the combustion process. In this process, energy is obtained by burning the waste directly, and we can obtain under controlled conditions about 30% of energy. Therefore, wastage of combustible matter is higher in this process, as you can see from the table 4. So, another process is dry chemical process, pyrolysis. In pyrolysis, the solid waste can be converted into oil, gas, and carbon char. The organic material is destructively distilled in the absence of air or oxygen. Very, very important thing that how the waste can be converted into usable product. As you can see from figure 1, the process of different type is shown in figure 1. The process is shown in a flow sheet. Shredder helps to reduce the solid waste into fine particle size. Magnet helps to separate ferrous materials. Iron material is separated with the help of magnet. Air classifier helps further to remove the inorganic. Froth flotation helps to recover glass from the inorganics. So if you have seen that here, different types of processes are occurring and different products are being recovered. ED current separator separates aluminum from the inorganics. Aluminum is being recovered, iron is being recovered, and that can be used for fruitfully for other purposes. Second, shredder further reduces the refuse into fine particle size. These fine particle size solid waste reach the flash pyrolysis reactor. Flash pyrolysis reactors occurs in the reactor at 500 degrees centigrade and at 101 kilo pressure without the presence of a catalyst. Catalyst is not being used, and we are converting waste into such a fruitful way. The energy recovered and the byproducts are also very useful. The cyclone separator separates the solid char from the product fluids. For the formation of oil, the temperature is kept at 500 degrees centigrade, and for the formation of gas and char, the temperature is kept at 700 degrees centigrade. The carbon char can be modified into briquettes for use as a solid fuel. Again, our purpose is to convert it into a fuel to obtain the energy. Mostly, this pyrolysis technique is used for the manufacturing liquid fuel from the solid waste. The process also has certain advantages and disadvantages. As you can see from the table 5, it has been shown that it has certain advantages, disadvantages. It is very well self-explanatory. Gasification. In gasification process, the solid wastes are heated in a reactor in the presence of limited quantities of oxygen to get synthesis gas consisting of carbon monoxide and hydrogen. The oxygen which comes from the cryogenic air separation unit helps to maintain the temperature at 1600 to 1700 degrees centigrade in the partial combustion zone. In this zone, at that temperature, the non-combustible substances are fused, whereas the organic materials are degraded to gases, liquids and solid char. As the gas rise and get dried, they preheat the charge before exciting at 250 degrees centigrade. The electrostatic precipitators help to remove the condensed oil droplets, tars and fly ash. They are recycled to the reactor for degradation to gases. The hydrogen sulfide and organic acids are separated from the gases by a neutralizing solution present within an acid absorber. In a condenser, the moisture is removed from the saturated gas. This way, the gas is obtained from the solid waste, but the gas obtained is not having equal heat value as that of natural gas. The gas produced by Purex process can be made equal to natural gas in terms of heat value. For this purpose, the gas produced by the Purex process can be methaneated to substitute natural gas through the reaction of carbon monoxide with water, which form methane and water. Prior to methanation, more hydrogen is produced through reaction. Carbon monoxide reacted with more water vapors and it forms carbon dioxide and hydrogen is evolved. To produce the substitute natural gas, the following arrangements are necessary: fixed bed or fluidized bed methanation reactors containing nickel or other suitable catalysts, pelleted catalyst in package tubes, and pelleted catalyst suspended in a fuel. The low medium energy fuel gas produced in the Purex process can be used to produce electricity. To produce electricity, a combined gas turbine system cycle method can be used. A Purex process for the production of energy is shown in figure 2. At a gas turbine inlet temperature of 980 degrees centigrade, an overall heat rate for the original biomass raw material of 12 megajoule per kilowatt per hour could be envisaged, giving a net delivered electricity efficiency of 29.4%, which is equal to the electricity derived from coal. Next is the aqueous processes. The important three aqueous processes are anaerobic digestion, alcoholic fermentation, and chemical reduction. To extract energy from the solid waste, the anaerobic digestion process is suitable. Therefore, the anaerobic digestion process is being discussed here. For in anaerobic digestion process, the solid wastes are converted into methane gas in the anaerobic digestion process. The process of making methane gas is shown in a flow sheet as shown in figure 3. The shredder helps to reduce the size of solid waste into 7 to 15 centimeter. Magnetic separator and screen helps to remove ferrous metal and fine grit and glass. The separation of inorganic and non-digestible material can be achieved by either a dry or wet system. For separation, in the dry system, the air classifier is used, whereas in the wet system, a hydropulper is used. Before reaching the digester, the solid wastes are mixed with nutrients as shown in the figure 3, and lime and ferrous are mixed in the mixing tank. The digester is a cylindrical tank just like biogas unit. In this process, also a steering mechanism is provided along with the floating cover. The gas produced in the digester contains methane and the carbon dioxide gas in 50 to 50 ratio. All vegetable waste must be biodegraded anaerobically to produce a composite fertilizer and biogas with suitable starters such as cow dung. However, the conventional biomass digester cannot be used as they require 10% slurry of waste material. Therefore, it is not economical as it involves large investment. Biogas may be sucked out of an open vegetable waste pit having depths in the order of 10 to 20 meters using blowers. It may not be possible to suck out the entire gas produced. A considerable portion of gas produced escapes to the atmosphere. So, students, let us summarize what we have learned in this module. In the present module, we have learned how energy can be generated from solid waste. Means not only the generation of energy from solid waste, but you have also learned how energy is generated from solid waste in such a way that the byproducts are also useful. Industry will adopt our process only when industry uh, has not the burden of excess of financial burden. It will accept our recycling process when it can use energy in a fruitful way, and also the byproducts are used in a fruitful way. Solid waste come from different areas like residential, commercial, and agriculture areas, which are being converted into byproducts with the side-by-side generation of energy. This you have learned in today's module. Thank you, students.